So I will have two switch 1, switch 2. Between switch 1 and switch 2 I have two link, 0/19 and 0/20, and here I have one router. You can consider this router as PC and user device. Here I have one PC, here I have one PC, and here I have one PC. Okay, like this. This is my topology. I am going to design this same topology in rack. Port number, let me write port number. So this is 0/0. This is not 0/0. This is 0/1. Before that, let me give the name to devices. This is my switch 1. This is my switch 2. This is 0/1 interface. This is 0/2 interface of switch 1. This is 0/3 interface of switch 2. And this is 0/4 interface of switch 4. Switch 2. 0/4. This is my router 1, R1, R2, R3, and R4. Okay, this is 0/0 of router 1. This is also 0/0 of router 2. This is 0/1 of router 3, which is connected with switch 2. And this is 0/1 of router 4, which is connected with switch 2. Done. Here let's say I will configure one IP address, that is 10.1.1.1. Here my IP address is, let's say, 10.1.1.2. Here let's say my IP address is 10.1.1.3, and lastly here I have IP address 10.1.1.4. Okay, so hope topology is clear to you, and link between switches is 0/19, 1/0/19, and 0/20. 0/1/0/20. Fine. Hope this topology is clear, guys. I'm going to use this same topology in rack, and after that we will bundle these two link through ether channel. Through ether channel we will bundle these two link. Here let's say this is my port channel. Port channel is the virtual interface. This is port channel 10, P10, and here also, here you can configure different port channel as well, right? Port channel group number is locally significant. We can configure same also, and we can configure different also, but let me configure same for the troubleshooting purpose. Okay, this is my topology. I'm going to copy this topology and let me paste this topology in whiteboard so that topology and console both will be visible to you. New topology, start with blank, and here I'm going to, where is the pen? Let me copy the diagram and let me paste the diagram over here. Okay, fine. Now here I have console. Are you able to see topology as well as console?
Yes.
Right. Now I am going to access routers. So let me clone the session one more time. PM networking and router 1. R1, this is R1. Then let me clone the session one more time for R2. R2, this is R2. Let me access R3 also. This is R3, and let me access R4. Done. I have accessed all the devices of my rack. This is R4. Now, as you know, I am going to down first all interface of this switch, and I will up only those interface which I am going to use in this scenario. Interface range F1/0/1 to 24 say shutdown, and then I will run no shutdown, only on 0/0, 0/1, 0/2, 0/19, and 0/20, which we are going to use in this scenario. So interface range F1/0/1 to 2, and then F1/0/19 to 20. I'm going to run no shut command on these interface. After that, let me do same thing on switch number 2 also. Interface range F1/0/1 to 24. I am going to down all interfaces, and I will up only those interfaces which we are using in this scenario. So I am using interface range F1/0/3 to 4 and F1/0/19 to 20. Say no shutdown. Fine. Then R1 on R1 F0/0 I am using only. So interface F0/1 say shutdown, and I am going to disable routing feature over here. No IP routing, and then I am going to configure IP address on fast Ethernet 0/0. That is IP address 10.1.1.1 255.255.255.0. Done. Then router 2 enable config T interface F0/1 shutdown, no IP routing. To disable routing on router, if you want to use router as a end devices, you have to disable routing by running this command. And then interface F0/0 IP address is 10.1.1.2 255.255.255.0. Done. I have configured the IP address on router number 2 also. Router 3 interface F0/0 I am going to say shutdown to this interface because we are using F1/0 over here, 0/1 over here, and IP address is 10.1.1.3 255.255.255.0, and let me disable the routing by running command no IP routing. Fine. Then switch 4 enable config T interface F0/1 IP address 10.1.1.4 255.255.255.0 exit interface F0/0 say shutdown to this interface and no IP routing. We have configured the scenario. Done. Now if you will check connectivity from router 1 to any router, or you can run what command to check directly connected devices? So CDP neighbor. So CDP neighbor. Guys, CDP is also layer 2 protocol which is used to check directly connected device. CDP is a layer 2 protocol which is used to check directly connected device. So CDP neighbor, it will show me the directly connected device. So switch 1 is telling me that your neighbor is switch 2 on 2 interface. After that router 2 is your neighbor and router 1 is your neighbor, right? So switch 1 is connected with switch 2 on 2 link, and switch 1 is connected with router 1 and router 2. right? You know, by default CDP is running, that's why we are able to see CDP neighbor. So CDP interfaces, it will show you the interface where CDP is enabled. So by default CDP is enabled on all interfaces, you can see. Okay, CDP is also a protocol which you need to learn. So let me discuss CDP also today. So CDP is an layer 2 protocol which is used to check directly connected devices, and you can see by default it is enabled on switches and sending CDP packet after every 60 seconds. So all devices is sending CDP message after every 60 seconds. But as you know, okay, that is fine, that CDP is enabled on 0/19 and 20. But why CDP is enabled on this interface? On F0/0 and F1/0, because F0/0, 0/1 and 0/2, sorry, not 0/0, 0/1 and 0/2 is connected with PC. And on PC we are not running CDP protocol. Then we have to disable CDP protocol on LAN interface. We have to disable CDP, because if you will not disable CDP, it will be sending CDP message after every 60 seconds. After every 60 seconds, it is sending one CDP message. Okay, so CDP, see how many command we have. One command is CDP entry. We can check, so CDP entry, and after that a star means all. So it will show you CDP entry for all connected device, like it is showing me. Let me maximize it. It is showing me the CDP details of switch 2, that this interface is connected, this device is connected through fast Ethernet 1/0, right? This is the interface of switch 2, not switch 1, and this is the interface of switch 1. And hold on time is 180 second. Here it's showing you that this interface hold on time is 150 second, means it is going to hold this information for 150 more second. But after 60 second, when it will receive CDP message, this timer will reset. Okay, hold on time by default is 180 second and hello time is 60 second, means after 60 seconds CDP is sending one message. So it is sending it is showing you the entry details of CDP. And here we have VTP domain name. We had discussed VTP or not? VTP?
No.
No. So we need to discuss VTP protocol also. Okay, so this is the CDP information. Next command that we can run to verify CDP is, so CDP and neighbor. So CDP interface we can run, so CDP entry we can run, so CDP neighbor command, and we can run so CDP traffic command to check CDP traffic. Okay, after that, on a particular interface, if you want to disable CDP, like as I told you, F0/1 and F0/2 is my LAN interface. So on these two interface I want to disable CDP. So you will go to interface range F1/0/122, and here you will run no CDP run command. So no CDP enable command. No CDP enable. By default CDP enable is enabled on all interface. This command is in operating system, CDP enable on all interfaces. So this is the command to disable CDP on a particular interface. In the same way, on switch number 2 also, I am going to say interface range F1/0/324 and no CDP enable. So it will disable the CDP on these two interface. Now if and on any switch, if you will check, so CDP interfaces, so CDP interfaces, now you can see CDP is running on fast Ethernet 0/3, fast Ethernet 0/4, 5, but CDP is not enabled on 0/1 and 0/2. Done. And if now we will run show cdp neighbor command, so it will show me only switches. After some time, after 80 seconds, it will remove these two entry. Getting my point? Clear cdp, clear cdp and counter and show cdp neighbor. So after 180 second means hold on time is, you can see 103 second. After 103 second, it is going to flush these two entry. Timer is resetting for upper entries, upper for these two entry, but timer is not resetting for these two lower entry. Getting my point? So after 80 second, it is going to flush this two entry. Fine. In the same way, switch 2 is also going to flush 2 entry after some time. So cdp neighbor, you can see after 32 second it is going to flush this entry, and after 71 second it is going to flush this entry. Okay, is it clear? So what is CDP protocol? CDP is a layer 2 protocol which is used to check directly connected devices, how we enable and how we disable. And if you want to disable CDP protocol globally, means on all interface you want to disable CDP protocol, then you will run commands no CDP run. No CDP run. This command will disable CDP protocol on all interfaces. Done. So if you want to disable CDP on all interface, you can run this command. Config t no cdp run, and now cdp is disabled globally. So if you will check show cdp neighbor, so it will show you that cdp is not enabled, brother. It's saying, brother, cdp is not enabled. Why you are running this command? Okay, and on switch number 2 also you can verify. So cdp neighbor, cdp is disabled. On 0/20 port, I think I have some problem. That's why I'm getting some error. On 0/20 links, I think there is problem with cable. Getting the error. So let me do one thing. Let me once plug in and plug out and plug in the cable again. Wait. I think there is some fault in cable, which is 0/20, which connects 0/20 ports of switch 1 and switch 2. There is some problem with cable. Actually, I need to replace that cable. I need to replace that cable. Link is flapping. You know, sometime in real time also you will get this type of error. That link is flapping between port number 0/1/20, 1/0/20, and you need to troubleshoot. So if you will get this type of error, so this is actually physical problem. This is not the problem of protocol.
So here I have a question.
Yeah.
The two router, why two router connected to the one switch? It should be like PC, like two PC connect to
This is
the
PC.
switch.
If I have disabled the routing on router, so router is not performing routing now. This is like PC.
Like in real time. We
Yeah,
should
in
use
real time
PC,
it is
not
PC.
router, right?
Actually, in my rack I don't have PC. That's why I'm using router instead of
Right.
using PC. Just I have disabled the routing there, and I am using the router as a PC.
So can we do like configurations in PC as same like a router, like how you did here?
Only I have configured the IP address.
Okay, good. Okay,
Only I have configured the IP address, nothing else. Got
got it.
it? Now you can see I am not getting error on 0/20 port, but there is some problem on 0/20 port. After the class I will change the cable between 0/20 port. Okay, till here everything is fine. We had just
Yes.
discussed CDP protocol. Now we are going to bundle these two links between switches through Ether channel, and I am going to use which protocol? LACP protocol to bundle the link. For now, if you want to check the connectivity between PCs, or you can say router, so I am going to ping 10.1.1.2. so you can see I am able to ping router 2, and in the same way I can ping router 3 also, right? And I am able to ping router 4 also. Means all PCs are able to communicate with each other. But the concern, the things here you need to understand is, so a spanning tree protocol, STP. In a spanning tree protocol, you can see 0/19 is root port and state is forwarding, and 0/20 is in blocking state. Yes or no?
Yes.
So switches have block 0/20 port. Only 0/90 port will used for data forwarding. Only 0/90 port is used for data forwarding. But if I want to use both link, so STP will not allow me to use both link. So that's why we come up with Ether channel. If I will bundle these two links through Ether channel, then STP will not work on these two physical port. STP is going to work on that logical port. Okay, so see how I will create the logical port. And guys, whenever you are creating a port channel, first of all you should down the interfaces. So I am going to run interface f1/0/19 to 20. First I will down this interface range f1/0/90 to 20. First of all I have down the interface. I will do same thing on switch number 2 also. I will down the interface first. Interface range f1/0/19 to 20 shutdown. Okay. On both switches I have down the interface. Right. And the next command that I am going to run is port channel. See, on this two interface, I want to bundle these two interface. So first I have shut down these two interface, and now I am going to run command channel group. Channel group. After that, group number, and then mode. As I told you in last class also, mode. This time I am going to use LACP protocol. So mode of LACP is active and passive. So either you can use active or you can use passive. If you are using active, that means it will initiate the negotiation, and passive will always wait for the negotiation. So let me configure active over here. So creating a port channel interface, port channel 10. In the same way on switch number 2 also I am going to create one channel group. Channel group number can be same or can be different, and then mode, and here also I can use active mode as well as I can use passive mode. So let me use active, and then I am going to run no shut command, because if you will not run no shut command, then your port channel is down. Do so IP interface brief. You can see the port channel which I have just created is down. Yes or no? So I am going to run no shut command here now, and on here also I have run no shut command. So now port will come up, and when port will come up, this on this two port, now a spanning tree protocol is not going to be enabled. A spanning tree protocol is going to be enabled on logical port. Let me show you. So a spanning tree protocol. Now you can see a spanning tree is running on this port, and this port is in forwarding state. This port is in forwarding state. That means now we are using both link 19 and as well as 20. 19 as well as 20. Here also we can verify by running command show spanning tree. So STP is running on port channel. Earlier spanning tree were running on 0/19 and 20. Because of that, one port was in blocking state, but we have bundled the link. That's why spanning tree is running on the logical port, and we have only single logical port, so spanning tree protocol is not going to block any link. So now we can use both link between switch 1 and switch 2 for data forwarding. Okay. Okay, now we have some verification command. Let me run all verification command one by one. First, show ether channel. In ether channel, we are able to see that we have created group number 10 and group state is layer 2. The how many port we have bundle 2, and how many maximum port that we can bundle 16. As I told you that LACP support up to 16 link. So we have bundled 2 link and maximum port that we can bundle is 16. After that, port channel max port is equal to 16. Maximum port that can be in one port channel is 16. In one port channel, maximum port can be 60. And the protocol which we are using is LACP. Done. Till here, any doubt to anybody? In last class also we had discussed this. Any doubt till here?
We don't have any idea about LACP.
You know, there are 3 types of mode. There are 2 protocol to form ether channel. If you want to form ether channel, you have 3 option. First is static. First method is static method by using on mode. Mode of static is on. Second type of ether channel configuration is dynamic. And in dynamic we have 2 protocol. First one is PAGP and second one is LACP. If we are configuring PAGP, then we have again 2 mode. One is desirable and auto. And in LACP we have 2 mode, that is active and passive. So if you are using what mode? On mode. That means your ether channel is static. If you are using any mode from these 2 mode, then you are configuring, that means you are configuring PAGP protocol. And if you are using any mode from these 2 like active and passive, that means you are using LACP protocol. So here on switch number 1 I have used active mode, and on switch number 2 I have used what? Passive mode. You know, here you can see you have 2 options, multiple option. Interface range F1/0/19 to 20 and channel group mode and channel group number 10 and then mode. And then if you will put question mark, you can see either you can configure mode what? Active, or you can configure mode what? Auto, or you can configure mode what? Desirable, or you can configure mode what? On, or you can configure mode what? Passive. So if you are configuring active and passive mode, that means you are configuring LACP protocol. This mode will enable LACP protocol. This mode will also enable LACP protocol, and desirable and auto, these 2 modes will enable PAGP protocol, and on mode is the static method. Is it clear now?
Yeah, so we don't have to configure like how we configure OSPF or the protocol.
No.
Got it.
It depends on mode. What mode you have used? That mode is depend on the protocol. In what is the difference between PAGP and LACP? PAGP is a Cisco proprietary protocol and LACP is an open standard protocol. In PAGP we can bundle only 8 link. In LACP we can bundle up to 16 link. Got it?
Yes. Can you check the record? Is the record is on?
Yeah, recording is on.
Okay, good. Thank you.
And here we have use active and passive mode. That's why it's showing you protocol is LACP. So first command is show ether channel. By running ether channel, we can check the protocol. We can check how many port we have bundle and how many maximum port we can bundle, right? And the protocol and what is the group number. Second command is show ether channel summary. This command will show you which ports you have bundle. This command is showing me fast ethernet 1/0/19 and fast ethernet 1/0/20 is bundled in this port channel. And here also we have information about protocol, that is protocol is LACP. Getting my point?
Yes.
Here we have SU. What is SU? Here you can read S means layer 2 and U means in use. And this P is what? Port in channel. Got it?
Yeah.
Got it, guys? Everyone, is it clear? This is the second command. First command is show ether channel. Second command is show ether channel summary. Then show ether channel and put question mark. You can see the detailed information. You can use group number over here. Group number, let's say 10. Group number 10. And then we can use detail command to check detailed information of this port channel. After that, if you want to check port, you can use port. You want to check protocol, you can check protocol, which protocol we are using. Summary, in summary it will show you the ports which you have bundled. So I am going to use, let's say, detailed command. So detailed command is showing me the detailed information of port channel configuration on every interface. First, this is the header information. This is the header information, same output of show ether channel. But here you can see port number 1/0/19 is a member of port channel, and this on this port you can see port state is up, master associate in bundle. Okay, leave it, this is not for you. Then channel group is 10, mode is active, what mode you have used over here is active. And then again, this is the port channel group. The port channel group is 10, and then these are the note information for you. Protocol, that is LACP, and pseudo port channel 10, this is also not for you. After that, in the same way, we have information about other interface like interface 0/20. Getting my point? Here we have the same information about 0/20 port number. So this is also one verification command we can check. Here with the help of this command, we were checking the mode, that which mode we have used. So we have used active mode. If you will run this command, same command on switch number 2, on switch number 2 also I have used active mode, so there also it will show you active mode. I should use passive mode there so that I can show you. Okay, so this is third troubleshooting command. Through this command we can check detailed information of port channel configuration on port. After that, show ether channel, and then we have discussed this load balancing. We can check what load balancing algorithm by default switches is using. So it is using source MAC address. After that, we can use load balancing algorithm, then we can use port. This command will show me the same output of show ether channel, port, and then detail. Same output. There is no any difference in output. Same output. This command is actually also used to check detailed information of port channel configuration on particular interface. After that, port channel. This is port channel. Port channel. By running this command, we can see group again. Group number is 10. Channel in the group, and primary Aggregator. What is the meaning of primary aggregator? Aggregate means what, guys? Combining or bundling multiple link. Yes or no? Aggregation. So this port channel is primary aggregator. One switch maybe switch 1 and switch 2. Out of these two switch, one switch will be primary and one switch will be secondary. If I will run this command on switch number 2, I am going to copy this command and let me use this command on switch number 2. Here also it's showing you primary aggregator for port channel. Actually we are using LACP protocol, so this is why. Okay, we will discuss this as well. That is system ID. For that you have to understand system ID. That is, you know, very advanced concept of LACP protocol. In CCNA, LACP is the only protocol in CCNA. You just need to understand what is the mode of LACP and what is the difference between LACP and PACP. Otherwise there is lots of things in LACP protocol, because LACP is the protocol which we are using in real time. Most of the scenario we are using LACP protocol. So there is lots of things to learn. Then we can use protocol command to check protocol LACP, and then lastly we can use, I think, summary command. So in summary we will find the ports which we have bundle, and so channel we have not any command like show channel group. Okay, so whatever verification command is there, that command is starting with show ether channel. Okay. Okay, and now
Yes.
let's say I want to check that when router 1 is going to ping to router 2, router 3, because router 3 is connected with different port, right? I want to check, guys, MAC address of router 1. So interface f0/0 include, this is the MAC address of router 1. I'm going to paste this MAC address over here, let's say. This is MAC address of router 1. If you will convert last value in binary, then what will be the binary of 8? Binary of 8 will be what? 1 0 0 0. Yes or no? Binary
Yes.
of 8. Okay. So switch is going to use port number. Which port number switch 1 is going to use when R1 will ping to R2? How I will verify that? I can check input and output traffic. First of all, I can clear counter interface f1/0/19. Clear counter fast ethernet 1/0/19 and clear counter fast ethernet 0/20. I have cleared the traffic on these two link 19 and 20, and now I am going to check so interface f1/0/19 and say include packets output. So there are 5 packets output on 0/19 port, and there are 26 packets output from fast ethernet 0/20. Now let's say I am going to ping R3 from R1 to R3, ping 10.1.1.3, and let me send 1000 packet. So it will use any one link between switch 1 and switch 2. So switch 1 is going to use one link. I want to verify that. So see, traffic output count is increasing on which port? On 0/20 or on 0/19?
20.
20. That means switch 1 is forwarding traffic from 0/20 port. Getting my point?
Yes.
So why it is using this port, 0/20 port? Actually, switch is performing load balancing between switch 1 and switch 2 over these two link, and it will check that what is the binary of last value in the source MAC address. So this is the binary, and we have only two links. So to represent two link, one bit is required. So it is going to use last bit, that is 0. It will convert 0 into decimal, so value will be 0. So it is going to use link number 1, and this is in 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 LACP protocol. Upper link is port number 0 and lower link is port number 1.
Okay.
Okay, so that's why it is using this link, lower link. It will use which link? Link number 2. If you will check MAC address of router 2, let's say, so interface F0/0 include MAC address of this interface is again 0. MAC address is again 0 here. So when this router will ping to PC number 3, which link switch 1 will use? Now you tell me.
20.
Repeat 1000, and here you can see ping is working 0/20, 0/90. This time it is using 0/90 port number.
Why?
Why? Because by default, as I told you, that source MAC address algorithm is not running. By default, source MAC address algorithm is running on most of the platforms. But when you are using LACP protocol, then so algorithm will be different. So on switch number 1, I am going to change algorithm, load balancing algorithm. How? Port channel load balancing algorithm, and I am going to say source MAC, source MAC. And on switch number 2 also I'm going to say channel port channel, then load balance source MAC. Where is 0/20? Packet count is increasing on which port?
19.
19. Let me check again the MAC address of router 2. I think so. Interface F0/0. It is 0 in the last, so decimal value will be 1. Okay, let me do one thing on router number 3. So interface F0/0 include here also MAC address is 0. Can I change router interface MAC address? I never did this. Interface F0/0 MAC address. Yes, we can change MAC address. I'm going to set any different MAC address over here. 111 dot dot mail form hexadecimal value. So MAC address should be different. Let me use ABCD.
You put one extra. Yeah.
MAC address is still that one. We cannot change MAC address. But why we have option then? MAC address. And here it's saying MAC address. Let me put this MAC address over here. And then it's saying clear. Command is available, but I am not able to set. Let
You
me,
can type, you
yeah,
can copy router 1 MAC address and just change the last digit.
this one.
No, router 1, the one you paste on topology.
Okay, let me check that this MAC address. Yeah, I am able to set this MAC address. Right now, the binary will be what? Over here, 00001. It will convert the value in decimal. Decimal value will be 1. It will use link number 2. So let me ping again R3 with 1000 packet. Now ping is not working. Packet count is increasing on 0/20. That is fine. It should use link number 20 only. Yes or no?
19 is increased in 20.
Why ping is not working? Ping is working. Yeah, ping is working. And switch is using which link? 0/20. Switch is using 0/20 link.
Yeah, now it's good.
Because it will convert last bits in binary, so last bits will be 1. And when R1 is pinging, that time also it is using which link? Let me clear once more time the packet count. Here I am going to say clear counter fast ethernet 1/0/19 and fast ethernet 1/0/20. Packet auth from fast ethernet 0/0 is 0 and packet auth from fast ethernet 0/90 is also 2. Let me ping from router number 1. So router 1 is pinging. Then let me check which link it is using. It is using 0/20. Okay. And when router 2 is pinging, then also I think it will use same link. Right. It is using 0/20 link in both scenario. Why it's happening like this?
Eh,
For router 1 it should use upper link 0/19, because router 1 have 0 MAC address in last, so interface F0/0 include. Here you can see MAC address is
Zero.
8 8 in the last, so in binary value will be 1 and 000, and here binary will be 1, so interface F0/0 include bytes. This is load balancing. This is really, not in your syllabus, but I was thinking to make you understand.
Yeah, if it's not important, leave it.
Mm, can we do one thing? Can we change load balancing algorithm again? Source MAC address, this is 4 bits value. Okay, let me, it will convert this value into binary, that is fine. Then it will use last 3 bits, last 1 bits, because we have only 2 links. So last bit, if last bit is 0, then decimal value will be 0. It will use link number 1. It should use link number 1, that is the concept only. Okay, I will check it, okay, personally after the class. Then I will, tell you that
Okay.
what was happening. Okay, don't
Okay.
worry. Except this, is ether channel clear?
Yes.
Now guys, next topic is VTP. Let me discuss VTP protocol today. VTP stand for VLAN trunking protocol. Here I am writing VTP stand for VLAN trunking protocol. Just give me 1 second, then I am starting it. Let let's suppose we have 100 number of switches in my organization, or 50 number of switches in my organization. Getting my point? Let's suppose we have 50 number of switches in my organization, and I need to create 100 VLAN on every switches. So guys, this is very complicated task to create 100 number of VLAN on every switches. Yes or no? If I have one switch, then maybe it is easy, but if I have 100 switch, then it is very complicated. Yes or no?
Yes.
So VTP is the protocol which is used to propagate VLAN database with neighbor switch. Like here we have two switch 1, switch 2. Whatever VLAN you need to create, just you need to create on switch number 1, and automatically switch 1 is going to propagate that VLAN to switch number 2. Switch 2 will automatically create that VLAN. That is called VTP. Switch 1, switch 2, switch 3, switch 4, switch 5. Let's say this is my one network. Okay, this is switch 1, switch 2, switch 3, switch 4 and switch 5. Fine. On every switches you don't need to create VLAN. Let's say on switch number 1 I am creating some VLAN. VLAN 10, VLAN 20, VLAN 30, and let's say VLAN 40. I have created this VLAN on this switch. And if VTP is working between these switches, then switch 1 is going to propagate this VLAN information to all switch. To switch 2, to switch 3, to switch 4, to switch 5 automatically. So if interviewer or anyone will ask you what is VTP, so what will be your answer? VTP stands for VLAN trunking protocol, which is used to propagate VLAN information between switches, or we can say VTP is used to centralize VLAN database. VTP is used to centralize VTP VLAN database. Getting my point?
Yes.
Now there is some requirement of VTP. Automatically it is not going to propagate. Let's see, in this scenario I am creating one VLAN on switch number 1. First of all, let me check is there any VLAN. So VLAN brief. Yeah, there is some VLAN, VLAN 10, 20 and VLAN 100. I am going to remove this VLAN first. No, VLAN 22, let's say 500. I have removed these all VLAN. Right, now you can check. So VLAN brief, these are default VLAN. We don't have any new VLAN on switch number 1. Let me check on switch 2 also. So VLAN brief, there is also some VLAN. Let me delete this VLAN. No, VLAN 22 200. Done. So VLAN brief. I am going to create one VLAN on switch number 1. Config T VLAN, let's say 100. Here I have created VLAN 100. So VLAN brief. But is this VLAN propagated to switch 2? So VLAN brief. No. Yes or no? Switch 2 don't have VLAN 100. Yes or no? You know, by default VTP is enabled on switch, but there is some requirement of VTP. First requirement is VTP link between switches must be configured as trunk. Requirement of VTP is, there is only two requirement. First requirement is link should be trunk, and second requirement is VTP domain name must be configured and must be same. There is two requirement of VTP. Link between switches must be configured as trunk, and VTP domain name must be configured and must be same. So on this switch, you can see on switch number 1, command to check VTP database is VTP status. So VTP status. In so VTP status, we are able to see VTP domain name is CCNA, and on switch number 2, so VTP status domain name is CCNA. So VTP domain name on both switches same, but you know, by default this is not the by default behavior. Here I am going to delete flash and VLAN dot dat file. I have delete VLAN dot dat file. Sorry, delete flash VLAN dot dat. I have deleted VLAN.dat file on switch number 1, and on switch number 2 also I am going to VLAN information stored in flash memory. So that's why I am deleting flash memory. Delete flash and name of the file vlan.dat, right? And so VTP status. Now you can see domain name is still what? CCNA, but we don't have any VLAN. We have deleted the VLAN database, but still VTP domain name is, so VTP status. VTP domain name is still CCNA. So if you want to change, if you want to set the default VTP domain name, you have to do one thing. You have to change the mode of this switch. I'm going to set this switch mode is transparent mode. Here we cannot run, if you will check running configuration, so run in a running configuration we have one command. Just I want to show you that command. This is the port channel configuration. There should be one configuration, one command, that is VTP domain name. Actually in the flash memory, VLAN database is stored in flash memory, that's why we are not able to see this command in running configuration, but someone have run this command VTP domain name CCNA on this switch, so that's why domain name is CCNA. But if I will run no to this command, see this command is not working, but I can change the VTP domain name CCNP. So you can see VTP domain name change from CCNA to CCNP. Now domain name on this switch is CCNP and domain name on switch 2 is CCNA. Domain name is mismatch. So VTP domain name must be configured and must be same. By default VTP domain name will be null. Let me do one thing. VTP mode transparent, and so VTP status. Now VTP domain name is still what? CCNP. Now we can do one thing, how to set if VTP domain name has been previously configured, this will not occur also once you will enhance the switches VTP domain name of something other than null. So there is no way to change it back to null. So if domain name is configured, then there is no any option to change. There is no any option to change to default name. If VTP name is configured, then I have only one option, that is I can reload the switch. I can delete startup configuration, delete a startup configuration, and then I can reload the switch. Reload. Say no. See what will happen over here. Because we don't have any option. If you have configured the VTP domain name, then there is no any option to change VTP domain name to null again. If you will purchase a new switch from the market, then VTP domain name will be null. Okay guys. So here when I will reload the switch, then it will show me the initial configuration only, the configuration which is stored in operating system. So you will see VTP domain name null. Just wait for some time. So VTP domain name, if VTP domain name is null, then VLAN is not going to propagate. So as I told you, VTP domain name must be configured, must be same, and link between switches must be configured as trunk. Then switches can propagate VLAN information. Waiting for stuck master election around 30 seconds. And switch number 2 also erase startup configuration and reload the device. Switch 1 is booting. It is restoring the running configuration from flash memory, and you can see it have started. Done. First of all, I am going to change the host name. Host name switch 1, and let me write the configuration. And now show VTP status. What is VTP domain name still? CCNP. Still VTP domain name is CCNP, not null. My god. Config T VTP domain name null. So VTP status. Now you can see VTP domain name is null, but this is, not the default. This is the name of null, but by default you will see there will be nothing here. There will be nothing. So VTP name must be configured and must be same. I am going to configure one VTP domain name here. Let's say VTP domain name is CCNA. And on switch number 2 also, wait for some time.
I think it was null. It says change from null to CCNA.
Null is the character, but by default you will not see anything over here.
Oh, okay.
Okay, if I want to show you, then I can show you in packet tracer, because in packet tracer we will take one phrase switch.
And now you work in real device, right?
Right.
Okay.
On real device, someone have configured the domain name. Actually, I am giving access to these real devices to remote user as well. So someone have saved the configuration, someone have changed the domain name, and that's why we are not able to see null name. So VTP domain name. So VTP. So VTP status. Domain name over here is, you can see, this is the domain name. Don't know on switch why we have not got domain name null, but here you can see domain name is null. This is the default configuration. Getting my point, brother? Now this switch don't have any domain name. And if you want to propagate VLAN database between switch 1 and switch 2, you have to configure same domain name on both switch. So here also I am going to configure domain name, same domain name, that is CCNA. Okay. VTP domain name. Domain name is CCNA. Now VTP domain name is same on both switch. Here also domain name is CCNA, and on switch number 2 also VTP domain name is CCNA. Now second requirement is link between switches trunk. So interface P10, port channel 10, and switch port trunk encapsulation .1q and switch port mode trunk. I have configured the link between switches as trunk. Here also I'm going to say interface P10, port channel 10, and switch port trunk encapsulation .1q and switch port mode trunk. Now if I will create any VLAN over here, let's say VLAN 500, so automatically you can see on switch number 2 I have created VLAN 500 on switch 1, and on switch number 2 if you will check VLAN database, so VLAN brief, you can see VLAN 500 is created over here. It has not created, that means link between switches is not configured as trunk. It will take 30 seconds, just wait for 30 seconds. After 30 seconds you will see there will be VLAN 500, VLAN 501, VLAN 502, okay, and switch number 2 will have this VLAN. Wait, just give me some time. We already covered DTP protocol, right? Dynamic trunking protocol.
No.
Dynamic trunking protocol, DTP, no.
No.
So interface trunk, there is no trunk link. And on switch number 1, so interface trunk, there is no trunk link because we don't have port channel. Okay, I need to configure 0/19 as trunk, interface F0/19, switch port trunk encapsulation .1q and switch port mode trunk. Go to switch number 2, interface F1/0/19 and switch port trunk encapsulation .1q and switch port mode trunk. Now so interface trunk, okay, I have trunk link over here, and on switch number 2 also I have trunk link, so interface trunk, fine. And now I am going to verify VLAN database of switch 2, so VLAN brief. Still I don't have any VLAN, so now I am going to create any VLAN on switch number 1. VLAN, let's say 100, exit, switch number 2, so VLAN brief. It will take 30 seconds I think, and domain name should be same, VTP status, domain name is CCNA over here, that is fine. And on switch number 1, so VTP status. This switch mode is transparent mode, you will understand mode as well, VTP mode server, VLAN 101, exit, and switch number 2, so VLAN brief. Now you can see switch number 2 VLAN, so VLAN brief. All the VLAN is automatically created on switch number 2, yes or no? If I will create any VLAN on switch number 1, let's say VLAN 10 and name is Soha. I have created one VLAN 10 on switch number 2, and you can see on switch number 1, so VLAN brief. Automatically VLAN 10 is created over here and name is Soha. So how this is happening? With the help of VTP protocol. VTP is used to propagate VLAN information as well as VLAN name. Okay. Okay guys.
Yes.
Is it clear?
Yes.
So today we had discussed two protocol, Ether channel and VTP. Now in VTP we have some more concept that we will discuss tomorrow. Okay, so please remind
Okay.
me. We have some more concept in VTP, that is mode of VTP. Today we have just understand the requirement of VTP. What is VTP and the requirement of VTP. Okay, tomorrow we will understand the modes of VTP.
Okay.
Okay, thank you.
Okay, so any question from today class?
No.